In this video, let's understand the difference between a motorized damper and a motorized smoke fire damper. Motorized dampers are commonly used in HVAC systems to control airflow. When a signal is received from a controller, the damper opens or closes. This basic operating principle is the same for both motorized dampers and motorized smoke fire dampers. Then the question is, why are they called by different names? That's what we are going to see in this video. The type of damper selected always depends on the system requirement. If the damper is used only for normal ventilation control, a motorized damper is sufficient. But when the damper is part of an emergency smoke control system, it must be able to withstand high temperatures, typically up to 250 degrees Celsius. To understand this better, we first need to know the difference between normal mode and emergency mode. As shown in the table, all ECS systems serving essential rooms in a fire-rated building must remain operational during a fire event. This means that when a fire occurs, the fans serving essential rooms must continue running, while fans serving non-essential areas must be switched off. The table identifies the rooms classified as essential. Similarly, smoke control fans are also required to operate during a fire. For this reason, the dampers used with these fans must be capable of withstanding temperatures up to 250 degrees Celsius. Therefore, motorized smoke fire dampers, MSFDs, must be used for smoke control fan applications. During a fire, normal mode ventilation systems are usually switched off. Emergency mode systems are designed to operate even during a fire. For example, ventilation serving only rooms may not be required to run during a fire, but systems serving escape corridors, smoke stop lobbies, lift lobbies, and fire pump rooms must continue operating, as these are the main escape routes for occupants. Because these systems must function during a fire. Coming back to dampers, motorized dampers control airflow, while fire dampers are used to prevent the spread of fire from one compartment to another. Buildings are divided into fire compartments, often rated for 2 hours, as shown in fire compartment drawings. Although walls are fire-rated, services like ducts, pipes, and cable trays still need to pass through these compartments. Pipes and cable trays can be sealed with fire sealant and rock wool, but ducts cannot be fully sealed because air must pass through them. This is why fire dampers are used. Under normal conditions, the fire damper remains open. When a fire occurs, the fusible link melts, causing the damper blade to drop and close the duct opening. In certain areas, such as battery rooms, fire codes do not permit the use of conventional fire dampers. The intent is to prevent fire and smoke from other zones from entering the battery room. Therefore, an MSFD is provided at the battery room instead of a conventional fire damper. If any duct serving the battery room passes through another room or fire zone, the duct shall be fire-rated. However, this requirement does not apply to smoke exhaust fans, as smoke fans are required to remain operational during a fire. During a fire, the smoke temperature can exceed 70 degrees Celsius. However, a standard MD is typically rated to withstand temperatures only up to 70 degrees Celsius, which means the system may be affected during a fire. Therefore, MSFD is used in the smoke control system to ensure that the smoke fan can operate reliably in both normal and fire modes. If smoke fans penetrate from one compartment to another, meaning from one room to another, the ductwork must be fire-rated. This is because fire can spread between rooms through the duct, therefore, the duct shall provide fire protection for up to 2 hours. In addition, proper installation of the MSFD is critical. The MSFD shall be installed as close as possible to the fire-rated wall. If site conditions do not permit installation adjacent to the wall, the section of duct between the damper and the wall shall be fire-rated to prevent fire penetration through the duct. If this explanation helped you, like the video, share it with your site team, and subscribe for more practical HVAC explanations with simple animations.